Welcome to the IPCC Interactive Atlas landing page. By clicking on the regional information box, you'll be taken to an interactive map. Here you can explore various scenarios by querying specific variables, climate indices, seasons, and time periods. In this example, we select the CMIP6 GCM ensemble and choose to represent the bias-adjusted TX40, which indicates the mean annual number of days exceeding 40 degrees Celsius, after correcting for different model biases to obtain temperature magnitudes coherent with observations. We do this for the +3 degrees warming level scenario and select the future shared socioeconomic pathway 5A.5. We also specify that we want to represent the change, meaning the difference between the future period and the 1986 to 2005 baseline period. Finally, we are interested in analyzing the results for boreal summer, June, July, and August. As a result, we obtain a climate change map depicting the projected differences. So, what is the contribution of Metaclip to the interactive atlas? We can easily obtain a high-level schematic representation of the map by clicking on the Provenance button. An inspection of this schematic view will help non-expert users better understand how the map was created and what it represents. For example, we can better understand the procedure for bias correction by clicking on the corresponding box, where the trend-preserving CMIP3 calibration method is explained in more detail, including relevant references. We can also better understand the transformations undergone by the original model data by observing the graph. If we want to understand what the global warming level periods are, we can query the future simulation's temporal collocation step, where these periods are specified for each individual model in the ensemble. Similarly, we can explore the origin of all these models, including their digital object identifiers and native model horizontal resolutions. It is also possible to gain deeper insight into the TX40 climate index and how it is calculated from the temperature data. Also, specific details about the ensemble multi-model agreement depicted by hatched areas, along with other map elements such as cartographic projection, supplementary vector layers, spatial extent, and color bar characteristics, are all indicated in the final graphical product box. All this information is automatically generated from a more detailed low-level representation of provenance stored in a JSON LD file. This machine-readable structured file adheres to RDF standards and contains the full provenance description of this map. To download the file, we click the Download button. The resulting file, containing over 8,600 lines of text, can be further queried with more sophisticated tools if needed. Every map created interactively by users will automatically generate an associated full provenance description, including specific details such as the selection of arbitrary seasons or specific map boundaries. By leveraging the IPCC Interactive Atlas, we empower users to delve into climate data with unprecedented detail and clarity. The semantic model allows for a comprehensive description of data provenance, making it easier for both scientists, technicians, and non-experts to understand the procedures involved in preparing the map. This tool not only enhances our understanding of climate change impacts, but also fosters informed decision-making for a sustainable future. Thank you for joining us on this journey towards a better understanding of our planet's future.